Hello, this is a story about sound. Can you hear it? You can't escape it? It's everywhere. You open your window and you hear it. It could be the birds singing or the wind blowing in the trees. This is our galaxy, and I often try to tell people, can you see the magnet or the coils? There is none, because it's all powered by sound. You see the central sun here, and it's just like a giant ball of water bobbing in and out of a hole, lit up by radio frequency from vibration. And this is what's making it spin. Everything in nature has an opposite. There is light and there is dark. There is male and there is female. There is positive and there is negative. And there is hot and there is cold. And these are the things in nature that everyone readily observes. Okay, so here is a hurricane. Do you see the magnet or the coils? There is none, yet it produces hundreds of millions of volts and thousands of amps. Okay, so before I go any further, please like, share, and subscribe, and show this to at least 2 friends, because what I'm about to show you, it's going to blow your mind. Because what I'm going to show you is that the galaxy is actually a thermoacoustic process. And I'm going to show you how to build a galaxy in a box and how it works with no magnet, no coil, no battery, or any power source whatsoever. This video is for educational purposes only. Do not build it. It is a high voltage alternating current with high amps. It is only suited as a power plant, and it needs a ground rod or it will throw lightning bolts. I'm sharing what I discovered, but I waive all liability if you hurt yourself or anybody else. So if you're going to try to attempt to build this, you need a professional team that knows how to deal with high voltage and high amperage. Okay, so I'm asking you, please subscribe, because, I've spent 30 years on this, and I've never made a dime off this, and I've engineered every part. And if we could show this to enough people, and if you get 1 billion people to see this, you can change the world. So it's really up to you people, the rest of you, to bring this to the next level, so that everybody on the planet can benefit on an equal level. And in order for this to happen, I need to show everyone how this works. To begin, I have to show you some video clips of how certain things work to give you a better understanding of what is actually happening that is creating the energy. And at the end, I'm going to show you a galaxy in a box and how it works. So first, I'm going to show you this, the only part of it. You can watch the whole video yourself. I don't want to start stealing content from people, but there's certain things in here that are important. And this is about water droplets, how you can spin water droplets in a torus. And as the water droplets separate, they produce electricity from what they call charge separation. And so what this device is going to do, it's a musical instrument. It works like, okay, if you were to take a pipe, like a pipe organ, and it's a certain length, so there's certain things I call a node, like just like a wind chime. If you want to hang a wind chime and you want it to vibrate, you got to hang it at the node. And so to find a node on a musical instrument like a xylophone key or a wind chime, you have to measure 0.224 times the length, and that'll give you the measurement for the nodes on each end. And you can hang a wire there, hang the xylophone key or the wind chime. It's going to vibrate. But if you try to hold it anywhere else, you're going to dampen the vibration and it won't work. So this is all about sound vibration. And so, to start, what we're trying to do here is we're trying to create heat in the center of a donut. And this heat is going to make the air rise in the center. And the air is going to rise and condense into water. And it's going to spin like a donut. And the process that's going to make this happen the sound. Sound's going to create the heat, and the heat's going to make a sound, and the sound's going to vibrate a xylophone key that's going to bounce on these granite discs, they're piezoelectric, but they're in fact speakers that can reach about 20 million hertz. And so you're able to reach the frequencies that are going to split water into hydrogen. So we're going to get to that later. So before we get to that, you have to understand that you need a hole. Like, we have fusion reactors and they use big magnets, and it's just crazy because it's not going to work because you need the hole because the process is thermoacoustic. And if you have a chimney, the higher it rises, you already got motion, and the colder it goes down. So this is why and how it works. So first I'm going to show you how water and dust going through a hole can generate electricity. So here we go. I'm going to go to full screen. Here.
It makes no difference whether the liquid is conductive or not. When any liquid falls through space and breaks into droplets, static is generated and can accumulate on any nearby insulated conductive object. To prevent this hazardous accumulation, bonding is the answer. Now, as mercury flows through the funnels, no explosion occurs. Even water, by forming into droplets and falling through space, can generate a static charge. In fact, the greatest manifestation of static in nature, lightning, is generated in this way. This Kelvin water dropper consists of 4 empty cans with the tops and bottoms removed. There is a screen in each bottom can to collect the static. When water flows out of these nozzles and falls in droplets through the cans, sufficient static is generated to ignite the explosion tube. This small amount of falling water is all that is needed to generate enough static to explode a flammable mixture. Many other liquids are just as effective. Mr. Kintz will show us what happened in an ammonia manufacturing plant. A water solution was flowing into the top of a large tank containing a flammable hydrogen mixture. An explosion occurred inside the tank. It is believed that the water solution flowing into the top of the tank created the static that caused the ignition. Many people are under the false impression that humidity stops the generation of static. Just remember that our strongest manifestation of static occurs during thunderstorms, when we often have our highest relative humidity. High humidity does not stop the generation of static, but it can prevent the accumulation of static. Mother Nature does with humidity what should be done mechanically in industry. With a microscopic film of moisture, she bonds all surfaces together electrically, so there is no difference in potential. When two objects are bonded together, there can be no difference in potential and no spark can occur. Before you pour flammable liquids or permit them to flow from one container to another, be sure that the containers are electrically bonded, unless it's a closed system. A workman in a refinery was doing exactly what Mr. Brown is now doing, except the 5-gallon can and the metal funnel were not bonded together. Static generated by the falling liquid ignited the vapor. Because it is not possible to bond glass containers electrically, the liquid should flow in a smooth stream. Do not hold the container in the air and let the liquid break into droplets as it falls. In dry weather, when a man walks while wearing heavy woolen or synthetic clothing, the layers of clothing separating from each other may cause a heavy charge to accumulate on his body. You've seen liquids fall through space and generate static. Now, how about solids? The 2 pieces of tubing held by Mr. Brown are insulated from each other by a plastic ring. When air at low pressure is blown through the tubing, nothing happens. A clean, dry gas at low pressure does not generate static because there are no solid or liquid particles present to contact and separate. When a tiny amount of dust is added to the air, a sufficient charge is generated to cause ignition. Moisture, dust particles, rust, and other impurities can contaminate natural gas and make it a static generator. This equipment demonstrates how fires have started while sulfur was being loaded into a ship through chutes or piping. Using this equipment, Mr. Kintz and Mr. Brown have tested flour, rust, sulfur, coal, grain, catalyst, and many other materials. They all generate static. If a high-pressure gas line ruptures, many people think that mechanical sparks or heat of breakage ignite the gas. But these conclusions are often doubtful. The probability is that the escaping high-pressure gas creates dust clouds, and the dust particles generate a static charge which ignites the gas.
We know that when you have water droplets, they separate, they create static electricity, and it's going to build up, and also dust. So what I've made is a device. It has a hole, and it's in the center of a box, and so the air flows through it, and if dust goes through it or water droplets, it's going to create electricity. Okay, so we're going to get to the next thing about acoustic energy, because this is a thermoacoustic engine. And like I said, I don't want to play the whole videos because I don't want to steal people's content, but I have to show you certain things so you understand the device when I start showing you the parts. Okay, so here we go.
The first thing I'll demonstrate is an interesting experiment which will give obvious meaning to the term thermoacoustic. We will use heat to make sound. This can be demonstrated by applying heat to an object which has a natural acoustic resonance, like a tube or a vial. A familiar way to hear the resonance of objects like these is by blowing over the mouth in such a way that the air inside begins vibrating and you hear a tone. Many different instruments work by taking advantage of this resonant property, usually initiated by the flow of air from your lungs, but the same result can be achieved with a careful application of heat. In this quartz tube, I have a coil of nichrome wire suspended 1/4 of the way from the bottom. This is the same wire used in a toaster or hair dryer to generate heat when electricity is passed through it. If I turn up the voltage, the wire will begin to glow red, which produces heat, and we should hear a sound.
This is what we're trying to do. You're going to see it soon. So what I have is a device. It looks like an hourglass, but it doesn't have the bowl facing down. It just has the bowl facing up. And there's a hole in the center, and I'm heating that exact spot, and that exact spot is 0.224 times the length. But instead of a straight pipe, like you need to get 90 hertz because you got to match the xylophone key that goes on top. So you have to tune it to get a 90 hertz tone. And so what I've done is I've made it into I've expanded the top, and I've made it into a singing bowl, and I've mounted it on a piezoelectric disc. Now, piezoelectric discs, you can get them, they're cheap, they're little wafer things, and you can put sound through it, but you can't really hear it unless you put a cup on it. Now, when you put the cup on it, it amplifies the sound coming out of it. So what I've done is I've taken this singing bowl, and I've mounted it on a granite disc. It's 12 inches in diameter. It's also highly piezoelectric. In fact, you know, if you research this, 500 pounds of force on a piezoelectric disc will release 12,500 volts per cubic centimeter. And the thing is, this is not like a piezoelectric wire that you're just going to click manually and it's going to burn your hands out. This is going to just vibrate, and it's going to release voltage, but the voltage that's coming out of this is more other voltage created from the water droplets, and this is what's going to really drive the power, because like any kind of free energy device, to be honest, there is no free energy. You need a fuel source, and I'm showing you how to condense water and use the water as fuel to make this work. And this is by any laws of physics. So this device has two granite discs. Like this is just a tiny 1-inch disc, or not even whatever. And so it's much larger. But this gives you an idea what happens when you put sound through the piezoelectric disc, and then you put a bowl on it. It's going to turn into a speaker, and that speaker sits under a xylophone key. So you're blasting sound thermoacoustically through a hole. It's going to amplify through that speaker, and then got a xylophone key on top it's mounted. And so when the sound hits it, the same 90 hertz, that the xylophone key is 90 hertz, and the sound coming out of the hole is 90 hertz, and the box is also tuned at 90 hertz. And I'm going to show you how to tune it so that you get these exact notes, because these three things have to match. So but you'll see in a sec. So now we're going to show you how this piezoelectric stuff works. Okay, all right. So you see how that works. Okay, so now we're going to look at the device now and get ready to bounce. Okay, so I've showed you the hurricane and three principles that work in this device. There's other things happening, but it would take me too long to explain everything. But there's people out there much smarter than me that can do something with this. I don't have the resources to do this. And, maybe one day you'll want to donate to me. I have to set up a funding page or something. I just haven't done that yet. But anyways, okay, so we're going to go to my Tinkercad page. And so what we're looking at here, I'm going to give you an overall view. The computer's a bit slow. Okay, so this would be an assembly drawing when it looks, there's the singing bowl and there's the xylophone key. This would be the speaker seat. You got a piece in the center that's going to hold these two discs together. These are granite discs here. And, one goes on the top of this, and the other one goes on the other one facing down. So the center is free floating. It's going to bob up and down in the center. This is the piece that goes underneath. You see the hole that goes through. This is a tune drum box. That's the box itself. And this is the box top over here. And it's got a hole on top, and there's two pins, and there's two holes, and they're right at the notes. So whenever you deal with music, you got to find the notes. And so I explained it earlier, 0.224 times the length. And that goes for the box too. It's got handles on it. You can only put these handles at the notes. And, so you have to measure top to bottom. That would be your length, whatever. And it's same with, side to side if you put something the other way. But 0.224 times the length. Okay, so before I show you the main part that goes inside, which is right here, we got to understand something about the box. This is a special box. And the thing is, like anything, you make some a certain shape, and it's gonna vibrate to a certain note. And so what we're dealing here is F sharp 432. And I have a smaller box here in my closet. It's 15 inches by 9 inches by 9 inches, and it vibrates exactly 360 hertz. So if I hold it and I turn the music on, I turn it on YouTube 360 hertz. If I hertz, that's an example of wireless technology, and you can make things vibrate. Okay, and it's a 90 hertz drum box. It's 45 inch, 27 by 27 inches, and there's a reason for this because it's tuned to 90 hertz. If you make it any other size or shape, it's still going to be 90 hertz, so it's going to be out of tune with the singing bowl and the xylophone key. So you have to match those three. And so what's important about wood is like this device is going to get hot, and all the heat is going to go, all the cold is going to go down because you got a hole in the center. It's like a black hole, and so all the air is going to get sucked through it. And so what happens when wood gets hot? It vibrates violently. So when this thing starts to vibrate 90 hertz on its own. So when you line this with gold, it's not a capacitor because you're going to put gold inside and out. And the reason why you're using gold is because gold becomes magnetic when it gets hot. So if you did this with iron, iron loses all magnetic properties when it gets hot. So you need that magnetism. And the reason being is because you're going to have a spinning galaxy in that box and you got to contain it. So the gold is going to make the whole thing magnetic. It's going to vibrate. You're going to have a vibrating magnetic field on the outside of it. I can make these downloadable. If you have a CNC machine, you can readily make the parts. Some of them are quite simple, like the box anybody can make. You just have to make sure it's in tune. Because we're going to look at the lid of the box and the xylophone key. And so this is a 90 hertz xylophone key. It's very heavy duty. And if you were to hit this with a hammer, you would hear it for miles. It's so powerful. But it's not meant to be hit with a hammer. It's not meant to be a speaker in its essence. What these things are called transducers. They're both microphones and speakers. So being that it's a very powerful microphone, if you hit it with a hammer, you'll hear it for miles. It's also going to pick up sound for miles because it's very heavy and it's going to bounce on the box. And so this sits on top of the box, but inside the box is that sandwich uh, hourglass thing. And when this thing's bouncing, it's putting weight on the disc, and the discs are vibrating. It's going to make the center bob up and down. So this is basically, and this is how you mount it, so it's got grooves in it. And so you have a hole. If you download it, you'll find the size of the hole. But generally on a guitar box, it's about 3 inches. And I think I made this one a little bit bigger. I can't really remember the size, but it's in there. We're going to look at the granite speakers because this is a really important thing. It's the speaker that'll reach 20 million hertz, and and it's going to take heat, and especially the speaker facing up, it's going to get really hot. And they're like thermal conductors, but like I said, it's going to be pushing sound out of it, and it's also going to be transmitting heat to the center of the dome, which is going to blow like a horn, blow like a horn. The xylophone key is going to bounce on these discs. And because they're joined back to back, but they don't touch each other at the backs, they're joined back to back. There's a 3/8 to an inch space between the backs, so they don't touch. So when they're sandwiched like that, only the center can bob up and down, and the sound's going to go through it. So we're going to mount a bowl on the top facing up, and it's got a hole in it so the airflow can get through it. Water's going to condense, the hot air is going to come up the center. But you have a groove here around it. And I've made it like this because if for some reason it doesn't work, you can always put a magnet in here. And same with the other one, you put opposing magnets. And a lot of people already know how this works, but I honestly don't think you're going to need the magnet because this is going to become a magnet because the current's going to conduct through these discs and they're going to become electromagnets as well as speakers. There's a lot of things going on here. And so they're going to get hot because you're going to have current going through it. And so the heat's going to go to the center and it's going to transmit to that center cog that I showed you that's going to bob up and down. And it's connected to the hole that goes through the center, which is going to make it blow like a horn. And it's going to make sound. It's going to sound like a transformer, like with a low pitch sound. Okay, so, ask yourself, where have you seen these discs before? Like maybe 12,000 years ago, I'm not going to go further with that one. But so these are granite discs, rose granite. red granite, something with a high quartz content. And the reason why we're using granite here is because granite, for one, it's piezoelectric, not as much as quartz, but there is a lot of quartz in this. But because they're very elastic, it's going to take a pounding because you're putting a 454-pound xylophone key that's going to sit on the outer edge of this, and it's going to transfer the sound through it, and they're going to get hot too. So the disc facing down is likely going to get cold, but the one facing up is going to get hot. Like you're going to be able to fry eggs on it, but you're not going to want to get near this device because it's so dangerous. So you have these granite discs. Around this edge is where the seat sits on it. You have to make two of them. And in here is where the bowl sits, so you have a bit of a space here. And then water's going to come in here. And it's going to cause, like, the center is going to be positive, and the outer edge is negative, so it's going to conduct across the water. And what happens if you take AC current, and you throw it in water and you don't have a fuse, what's going to happen? You're going to melt the wire. It's just going to create a lot of heat. And this is what drives it. It's a heat engine. But it's primarily done with sound. Okay, so let's look at the next part here. Did I give you a close-up of the center cog? This connects to both discs and separates them by 3/8 of an inch. So they don't touch each other, but it connects them really well. And there's a lot of surface contact with the disc that's going to help, in the conductivity. But what we're really looking here for, there is piezoelectricity here, but that's more with the sound. The thermal conductivity is going to bring the heat to this, and this is going to get hot. And in thermoacoustics, you have the option. You could put a steel mesh in here, but I don't think you're going to need it because I think it's going to get so hot that it's just going to work without it. But if you have to, you put a mesh in here, like a screen, stainless steel or something, And so this thing's made out of, you can make it out of copper. You can add some silver to it. It'll help it conduct better. You can put gold in it. It'll make it more magnetic because it is going to get hot. You can try those three options. There's 7 sacred metals, but you don't really need to use mercury. But every metal has a different property. But the one you're focusing on is conductivity, which copper does fine, but silver does better. And, if you want magnetism, you're going to have this thing bobbing up and down in the center. And so if this is magnetic when it gets hot, if it's partly gold, it's going to create a vibrating magnetic field, right? Okay, so this is how you get a magnetic field with sound, with no wires and no coil, Okay, so now let's look at the next part. These discs they'll become a water-cooled electromagnet, basically. So you have the speaker seat, top and bottom. If you look here, you see it. But I'm going to show you the bottom connector first, because there's something really important I have to show you on this piece. Because there's one thing missing in these diagrams, and I did it on purpose. It's not to deceive people or nothing, but when you're dealing with thermoacoustics, you have to get the length of the pipe precise, and otherwise it won't work. You got to get 0.224 the length. So the length of this is exactly the bottom of the device. You see the hole going through it. Now it's a 1/4 inch short of the mark. So what you do is you drill out the hole here, with a thread, go counterclockwise, and put in a hollow pipe, and the pipe's got to hang out about a 1/4 inch, and then you can put Loctite and lock it in place. But when you tune it, this is where you just put the round thing, thread it, rod in there, hollow, and just adjust it until you get in tune. So you get that, it's going to sound like a horn, because it's all connected, it's all going to get hot. But like I said, most of the heat's at the center cog. So this goes up through the center cog, And so, again, you could put gold in it, you could put silver, or you could just do copper or all three. So, with that hole. And you need that hole, because without the hole, how's the hot air going to go up the center? And you see, when the hot air goes up the center, well, it's actually cold air going because it's heating up, and it's sucking the cold air from the bottom. But when the air hits the outside of the box, it's going to turn into water. And so you're going to have spinning water droplets in the bowl. And it's going to spin like a torus upwards. And those water droplets are going to make a lot of electricity. Okay, so let's look at the bowl here, because this is a very unique bowl. And it's a singing bowl, But what I've done is I've taken a pipe and I've expanded the top because you need to get 90 hertz. And to get 90 hertz, you can't do it in a lot of lengths with the amount of area I have in the box. So I have to expand the top. So this is a special bowl. I'm going to explain it. But it's got spouts out here, and there's a reason for this. You can see the bottom. This is how it mounts. But like I said, if you have to put magnets, then you're going to change the design on the bottom. But like I said, I don't think you're going to need the magnets. So these are holes, and they drain from here, and it's facing up because water's going to condense in here, and it's going to be shooting upwards. So the water can't go through the center hole, but it can leak through the sides. And the reason why I'm letting it leak through the sides is you got to cool the disc. They're going to get hot, and so you need some sort of water cooling. So these spouts will allow the water to flow on that outer area of the disc. And what you want to do with these spouts is you got to bend them downwards, and you got to allow a 3/8 of an inch gap between these spouts and the seat that sits on the outer edge. And if you go more than 3/8, you're going to crack the disc because you don't want more than 70,000 volts going through the discs. Any more than 75,000 volts, those discs are going to crack. So, like I said, you bend them down, and there's going to be a gap between the bent part and the seat that's going to be around here, And so you see the hole because it's so important, that hole. And, I designed this little top here. This is so the water doesn't go back down because it's going to come up. And inside this bowl, it's going to be a torus. It's going to be spinning water droplets. And so this bowl is completely positive. It's separated from the seat, which is negative. And the whole box itself is negative. So the box inside out and out is negative. Everything's negative except the center part. And you're going to have a charge separation, and some of it's going to go, positive to the bowl and negative the rest of it. And so I just put this because, I was proud that I designed this. But like I said, you can cut this bowl with the CNC codes right now, but you're still going to have to tune it, and it's got to be 90 hertz to match with the xylophone key and the box. It's a tuned drum box. So I know it's a little bit crooked here. I should adjust it, but whatever. So that mounts on there. Now, the thing is, it's going to be threaded inside. I didn't put the threads in. This is going to mount and bolt tight together, so that bottom piece is going to hold it all together. You're going to have to put thread there or something, because this bowl has to rest firmly on those discs, because those discs are going to vibrate. They're going to transfer the sound to the bowl, and the bowl is going to blast to the underside of the xylophone key. That's going to bounce on this seat here, this seat right here. It's going to bounce on that. That seat only sits on the outer edge of the discs. So the centerpiece of the disc is completely, the pièce de résistance is this part here. You see what I mean? All the weight of that xylophone key is just bouncing on the outer edge. And so the only thing that can happen is the center is going to bob up and down. You can't see the centerpiece here, but you can see the bottom piece. There's a hole going right through it. And so all the cold air is going to go down, and all the hot air is going to go up. And it's going to suck through that hole. So that's the black hole there. That is a black hole. And, cold air coming up, meeting hot air. And then on the outside of the box is another air hole where it's going to be cold air. And so it's going to condense, and the water's going to end up in here, drain out these spouts here. It's going to cool the top disc, which is going to need the cooling because, like I said, it's going to get hot. And so, like I said, in the diagram, I didn't bend them down because when you cut this, you have to manually bend them. And so this is designed so that if you cut it, it's already ready to go. So this cannot touch the seat. This is a speaker seat here. There's two of them. There's two discs with centerpiece. So this bottom piece, you put a thread in it, and you thread it all the way up, but not right through, and it'll hold together. And that'll keep this firmly on the disc. So when the xylophone key is bouncing here, it's going to bounce on this. And like I said, there's nothing here. So the center is just going to bob up and down like a galaxy. And it's going to create a whirlwind, like a hurricane or a typhoon. The cold air go up, swirl around, and so the electrical part, there's a piezoelectric part with these discs, but the main energy is going to be the water droplet spinning. And what's going to happen is these discs they're speakers, and they have a range up to 20 million hertz. The water's going to split at 62,000 something hertz. You can look it up online what water splits into hydrogen at 62,000 hertz, so 223 or something, 62,223. So you're going to pick up these frequencies because these are not only they're speakers, they're microphones, they're transducers, and they have a range of up to 20 million hertz. So if these water droplets are bouncing around, they're making noise, it's going to hear it. If you made a UFO around this, and you tune the UFO to 1.45 hertz or 1.44 hertz, I think it's enough sharp note, very low frequency, you can't hear it, but it's the frequency of your heartbeat. So this thing's going to vibrate at the UFO or whatever, it'll vibrate at 1.44 hertz. But the thing is, your heartbeat is that frequency. So when you get in the ship, it's going to pick up your heartbeat. It's going to power itself from your heartbeat, from your breathing, from your walking, from every sound you make. And that ship is going to breathe in and out, and it's going to put pressure on the center here. And that sound is going to make the center bob up and down. So you're going to have a ship that's going to make its own air. It's just using recycling everything. There's already air in it when you begin with. It just reuses everything. And, you could probably go anywhere in the galaxy on about a cup of water or maybe a bowl of water because it's just going to use the same water over and over again. You're never going to run out. So, and the thing is, because water's condensing, this is inside a box you have to remember, so the bottom half going to get cold, and the top half going to get hot. And you got current going through AC. It's going to get really hot here. This is going to be bobbing up and down. And so all the cold air is going to get sucked in. It's going to go, whoa. And that sound is going to make the xylophone keep out. And the xylophone keep out is sitting on this. And so this is bouncing, making it, it's a feedback device. So, if you talk to it, you're going to hear your own voice. So to start it up, it's like any car. The old cars, you have to crank them. You need a starter, So to start this up, there's many ways. You can sing to it, very low frequency, like that, You just try to tune into that 90 hertz. But it'll take you a long time, because it's going to take a while to heat up. Or you could use a trumpet or a musical instrument, a tone generator. But the idea is to get the center here hot. And once the center hot, it's going to make its own sound. And it's going to power itself. So there's no wires on this because if you put wires on it, especially at the top, they'll melt. They will melt. So down here, you can attach wires. So if you want to pull power out of it, you're still going to have to make a transformer, which is going to cost you a lot more than building this device. But this seed would be negative, so you can connect down here. It's not going to melt the wire. So you got your negative. You still have to ground the box to a ground rod because it's alternating current. And like I said, you're going to get hit by lightning if you don't ground it. And so the positive is the center bowl, so you can connect to the bowl anywhere down here. Drill a hole, put a thing in, and run a wire here. But if you try to connect up here, you might melt the wires. So it's thermoacoustic. It's simple. Hot, cold, positive, negative. Everything separates. Charge separation. So the magic is the hole. So we have these. So everything's going to spin around it. It's going to spin counterclockwise, depending on where you are on the planet, because it's only really spinning one way. But if you're looking at it from the South Pole, it's spinning clockwise. If you're looking at it this way, it's spinning counterclockwise. So these are, things to fasten it to the box, The rest it's pretty easy. Free energy, whatever you want to call it, it's not free energy. You're using fuel. So whatever you want to call it, it's very simple. And you're being fooled your whole life. You're led to believe that the galaxy is like nuclear or thermonuclear or whatever. It's not. And it's not fusion either. You cannot make a fusion reactor work if you don't have the hole. You need a black hole. Plain and simple. So you look at the galaxy. How come nothing's going through the hole? Because it's spinning so fast. It's spinning so fast that nothing can really go through. There's just a big water ball in the center, and it's just bobbing up and down. It spends 12,000 years on each side. And so now we're halfway through the cycle. We're about in the middle of the plane. We've just crossed it. And so in about 6,000 years, the central sun, it's going to pop out of the hole. And it's going to light up this whole side of the galaxy. For 12,000 years, we are going to ascend. And to understand this further is like we're material now because we slowed down. But when we speed up in 6,000 years, we're going to dematerialize and we're going to become non-material beings. That's going to come, but not in our lifetime. But see, that's how this whole galaxy works. It's not, there's no magnet, there's no coil. It's thermoacoustic. It's a thermoacoustic universe. That's what it is. And, and it's all up to you. Everybody, thank you for watching. If you have questions, leave them in the comments and please subscribe and share this with everybody. And, I'm going to make these files available and you're going to be able to download the parts, but at your own risk, because I can't build it. I don't have the money. And, this requires a team. It requires people to work together. People have to love one another. They have to share. You got to care for each other. And this is what the world is all about. So good luck, everybody. And I'm glad I was able to share this with you. And, I spent 30 years on this, and maybe I'll put a donate button somewhere. I just have to figure out how to do it. And if you want to donate, I'll be more grateful. If somebody wants to interview me, I'd be happy to speak with George Galloway and maybe a few other people. There's Day, a French guy in Montreal, scientist. I would like to speak to scientists because I would like other people to come forward and validate this, because this is real and you don't need to plug anything in to get energy, but you have to understand that this is very dangerous. It is green energy, and it's possibly time travel because it's a device that gains mass. It makes its own water. It's going to gain mass. And on a larger scale, if you make a big ship and you tune it to your heartbeat, let's say 30 feet high by 50 feet diameter, you're going to have an F sharp in very low frequency, and if it matches with your heart, your ship is going to power itself from your heartbeat. And the thought process about consciousness, here's how it works. So you look at the galaxy, it's cymatic. You draw a flower of life on it, and there's nodal points everywhere. And you just have to vibrate those nodal points. You end up there, and you can see it on a cymatic plate, or you can see it with a xylophone key. If you put salt on it and you vibrate, the salt's going to move to the node. And that's how you travel in the galaxy. And it doesn't cost any money. You're going to use a cup of water, and you're going to reuse it again and again and again. You're never going to run out. So good luck, people. I'm not going to change the world. I'm not into political things. I hope the world can get together and make this happen. It's May the 5th, 2023. I've been sitting on this for 30 years, and a lot of people ask me, how does it work? And I hope I've opened your mind and given you better understanding of how we can all change the world. There's 8 billion people on this planet. We all got to live together. If 1 billion people can see this, it's going to change the world. It will, and for the better of all of us. So good luck, people, and good night.